When Apollo astronauts looked back at our Earth from space, they remarked that it looked like a blue marble. Small wonder when at least 75% of its surface is covered by water. Life as we know it cannot exist without water. So as we explore planets and other bodies in space, water is the one chemical that we look for first. We often take this simple substance for granted, thinking that our supply is limitless, but we could not be more wrong. In Chapter 2, we're going to be looking at the chemistry of life, but we will focus on the one thing that is the most familiar to everyone, water. It has some very special and very unique properties that are critical to its role in living things. So get your paper ready. Wide right, skinny left. Remember, do your notes on the right-hand side however you want to. See you on the next slide. As I mentioned in the last set of notes, water is a polar molecule. That means there is an uneven distribution of electrons. Remember that hydrogen shares its lone electron with the other molecule in what kind of bond? A covalent bond. It has only one proton, while oxygen has 8 protons. So even though it shares electrons, they tend to gather around the oxygen end of the atom more than the hydrogen end. So the oxygen end tends to have more of a negative charge, while the hydrogen ends tend to have more of a positive charge. And then water molecules attract each other kind of like little magnets. This causes a special type of bond, a hydrogen bond. No, not a hydrogen bomb. No, not James Bond. A hydrogen bond. This hydrogen bond gives water some very special properties, and these properties allow life to exist. So let's take a look at some of them. 2 properties of water are cohesion and adhesion. Both mean to stick together or cling, but they cling to different things. Cohesion is the attraction of like molecules, water to water specifically. The hydrogen bonds between water molecules create a web or a net of water molecules that creates surface tension. Surface tension allows animals like this water strider to walk on water. It also causes water to form perfect bubbles in space in the absence of gravity. Adhesion is the attraction of water molecules to other substances besides itself. This causes a phenomenon known as capillary action. Water climbs up the sides of the tubes in this picture because of the attraction of the water molecule and the molecules of the glass. If you were a tree, this would be critical to your survival. Can you figure out why? Water's property of heating and cooling are unusual as well. Heat capacity is a term you're going to hear quite a bit. Heat capacity is the amount of energy needed to raise the temperature of any substance 1 degree Celsius. Water has a very high heat capacity. It can hold a lot of heat. So it heats up very slowly and it cools down very slowly. Compare that to substances like iron or sand. They're quite the opposite. They heat up and cool down very quickly. So that means they have a low heat capacity. They cannot hold as much heat as water. This is why in the summertime most people would rather walk on wet sand than dry sand. Both are exposed to the same air temperature, but the dry sand absorbs more heat and heats up much more quickly, and it feels very hot to us, whereas the wet sand absorbs the same amount of heat, but its temperature doesn't raise as much. This also affects weather and climate patterns, and we'll talk a little bit more about that later. If you've ever seen a snowflake, you know that water, when it freezes, takes a crystalline structure or crystalline form. This crystalline structure takes up more space than a regular water molecule. So water expands as it freezes, becoming slightly less dense, which in turn causes frozen solid water to float on liquid water. Now, that doesn't sound all that amazing unless you're a water creature like a fish. Ice on top of water actually keeps the water underneath relatively warm, allowing water creatures to survive some pretty cold temperatures. It also allows kids like this to enjoy a sport that we here in Houston can only dream about: ice fishing. Water is known as the universal solvent. More substances dissolve in water than any other substance. Water can be a part of two different kinds of mixtures. Remember, a mixture is different elements or compounds not chemically combined with no specific ratio. Trail mix is a good example of a mixture. Air is a mixture. Water is not. Water is a compound. There are two types of mixtures: solutions and suspensions. In a solution, the molecules are evenly spread out through the mixture and they stay mixed with the water molecules until the water evaporates. Salt water is a good example of this. The dissolved substance is the solute. Salt, in this case, is the solute. The solvent is the substance that does the dissolving. In this case, water. So, as we said, salt water is an example of a solution. And when the water evaporates away, salt is left behind. You see that if you have a dark baseball cap and it gets all wet and sweaty, when you let it dry, it has all this white stuff on it. That's salt. A suspension is a mixture in which the solute particles are too large to mix very well with the solvent molecules. So instead, they settle out when it's left to sit undisturbed for a period of time, or when it's spun in a centrifuge. Blood is an example of a suspension. I can separate blood cells from the water and the plasma very easily. Chocolate milk is another. And medicine that you have to shake up before you take it is another good example of a suspension. Here you see three pictures. One is two are solutions and one is a suspension. Can you pick the suspension out? It's the cloudy one over on the right. Water molecules sometimes split apart to form ions of hydrogen, H+, or hydroxide, OH-. These ions, when in a solution, form an acid or a base. The pH scale measures the strength of acids or bases by measuring the concentration of hydrogen ions. The scale that they measure on goes from 0 to 14. 0 being the strongest acid, 14 being the strongest base. Here you see some examples of some different substances. Notice that pure water is neutral. It's in the middle. It does not have any hydrogen ions at all. Battery acid down at the bottom is a pH of 0. It's highly acidic. And then up at the top we have drain cleaner that is highly, highly basic. It's just as dangerous as an acid. Now, remember, acids, we said, form hydrogen ions in solution. On the pH scale, they have a pH below 7. Bases produce hydroxide ions, or OH- ions in solution. And they have a pH above 7. Here are some common household acids and bases. Okay? Baking soda and a lot of cleaners are bases. A lot of fruit juices are acids, along with baking powder, which is kind of puzzling to a lot of people, but there's cream of tartar in it that makes it acidic. Vinegar, lemon juice, orange juice, even vitamin C. Buffers are another substance related to acids and bases. The pH balance in living things is very delicate, and sudden large changes can have devastating consequences. A buffer is a substance that prevents these sudden changes in pH. Buffers are often used in medicine to help your body maintain homeostasis. If you have a saltwater aquarium or a pool, buffers are commonly used in the water to help balance the pH. And here you see an example of a buffer that would be used in a saltwater aquarium. The aspirin bufferin has buffers to help keep the pH level as close to normal as possible because aspirin can upset it. So lots of examples. So what now? We're done with the notes. No, not quite. You need to summarize this section, look back over the notes, highlight if you need to. Okay, remember if you're going to highlight with more than one color to color code and give me a key. Get with a study buddy or two and develop some questions. Use the book to help you develop questions. Remember, 3 level 1, 2 level 2, and 1 level 3 question. And then lastly, this says bring your notes to class on Friday 10-3 and 10-4. Yeah, I forgot to change that. You need to bring your notes to class on Friday 10-10 or on Tuesday 10-14. Okay, depending on when you have class, because we'll have a quiz over section 2 then. Okay, so you've written the questions, do the summary, or you've written the notes, do the summary, do the questions, and bring them to class and be ready for a quiz on October 10th and October 14th. See you in class, guys. Bye.